Welcome everyone to this design presentation of RoboTeam Twente. We are here at the Design Lab of the University of Twente, and we welcome you to our live stream. Unfortunately, due to Corona, we will be doing this fully online, and we would have hoped that you would have been here. But because of the circumstances, we are still happy that we are able to show you our plans today and have some interaction with you, which we will do during a discussion at the end. My name is Anne van Harte, and I'm the team manager of RoboTeam Twente this year. And with me, I have Lotte Steenmeijer, who is the technical manager of RoboTeam Twente, and she will be telling you all about our technical plans for this year later on. Hopefully, like I said, we can see each other after this presentation in the future in real life again, and we hope to be able to welcome you in our office as well. Especially our partners, we're really looking forward to seeing you in person again, because after all these years of Corona, we hope that we can finally pick up with real life events again later on in the year. So today, like I said, we will be giving a presentation about what we do as RoboTeam Twente. We'll be talking to you all about our design plans for the upcoming year, and we will end off with a discussion. But before we start, I have one announcement to make. We have been existing for 5 years now, and we are the 6th team, and we're planning to do something new. We're planning to change the brand identity of RoboTeam, and with that, I'm proud to announce the new brand of RoboTeam Twente today. Okay, welcome back everyone. So, welcome again to the design presentation of RoboTeam Twente, now in our new branding. So today we will be giving you a presentation in 3 parts. First, I will be telling you a bit about RoboTeam Twente, about what we do and about why we do it. Then we will be hearing from Lotte about all our technical plans for this year. She will show you the designs of what we have come up with and what we're planning to do in the next months. And at the end, we will have a discussion. We will do the discussion on an online platform where you can walk around and you can join all our different sub-teams in what they're talking about. You can ask questions, even if you already have questions, or maybe if you get questions during this presentation. So, let's first start off with our team. Our team this year consists of 25 people, and we are a very multidisciplinary team. We come from various different backgrounds and different studies, and also from different universities. Our team consists of people from the University of Twente, as well as from Saxion University of Applied Sciences. And because our team is so multidisciplinary, we have split our team up into 7 different sub-teams. I will be going through each and every sub-team individually to show you everyone in our team. First of all, we have the management sub-team, which me and Lotte are part of. But next to that, we also have a manager of external affairs and a financial manager. Next to that, we have a mechanics sub-team, and they focus on the mechanical components and the structure of the robots. Then we have the electronics sub-team, which focuses on the electronical components in the robot to make sure that the mechanical components actually work. Then we have the control sub-team, and the control sub-team focuses on making sure that our components do what we think they are supposed to do. For example, kick at the right speed instead of at a speed we cannot predict. So they use feedback for that. Then we have our artificial intelligence sub-team, which focuses on the software of the robot. But more importantly, they focus on the brain of our robots. So they really make sure that our robots are able to think for themselves and that they can act to their surroundings without us having to interfere. Then our last technical sub-team is the technical challenge team. And they focus on a technical challenge that we get from the RoboCup. The RoboCup is a competition which we'll enter, but I'll tell you more about that later in this presentation. Then lastly, we have our public relations sub-team, which focuses on the public image of the RoboTeam and also on presentations such as this one. And they've been working hard on the rebranding as well. So, with this large team of 25 people, we hope that this year again we can inspire and innovate in the fields of robotics and AI for yet another year. So the first thing I said was innovation, and innovation really is a big part of what we do as RoboTeam Twente. With innovation, we want to use all the knowledge that we get during our studies and give back to society. We want to make sure that with all this knowledge we can help society forward and use it in practice as well. So one of the ways in which we do that is by entering the RoboCup. The RoboCup, if you do not know it, is kind of like the World Championships of robot soccer. And next year it will be held in Bangkok, so in 2022. For this year, we want to qualify in the small size league. And the small size league is one that's quite comparable to soccer, but of course is still different. But in this league, we compete with 11 robots against 11 robots from a different team. And in this league, teams from both universities as well as companies compete. For the small size league, we're also very restricted in size. So we have to deal with a very small robot of about 18 centimeters in diameter. And that brings up a lot of technical challenges, which Lotte will discuss more in detail in the technical part of this presentation. What we really like about the RoboCup is that it's very accessible. You can see how innovation is performed in something like soccer. When I tell you that we do robot soccer, many people already get quite excited, and that's what we want to do as well. We want to be able to show what robotics and AI can do in such an accessible way, such as soccer. And secondly, the RoboCup really encourages knowledge sharing. So for that, for example, this design presentation is live streamed on YouTube, and it's also publicly available. And other teams are free to watch it and see what our designs are. And that's also an integral part of the RoboCup, where you have to make things open source, such that other teams can look at it as well. And with that, we want to make sure that we can move forward as society and not really keep all our innovations to ourselves and keep it within a company. And we really like that vision, and we think it really suits our team as well. The second part that I discussed was innovation. And that's also a very important part for RoboTeam Twente. With innovation, or with inspiration, we really want to make sure that both the new generations as well as the older generations are as enthusiastic about robotics and AI as we are. So we do that in different ways. And one of the ways in which we try to inspire people is by giving workshops. We give workshops at various different levels in society. For example, at primary schools, but also at high schools or universities, but even companies. So we try to tailor our workshops to different levels so people can get in touch with what robotics and AI has to offer and get excited about it just as much as we are. Another way in which we try to inspire people is by going to many events. And these can be events from partners, where we go to partners of us and talk about what we do to show all the people there what we as a team can accomplish. But also we go to things such as symposia and public events. And then a good example might be that we went to Military Book Club, which was a horse riding event, which had nothing to do with robotics, but we were there with our robots. and we were able to talk to a lot of people there and show them what our robots could do. And we do think we inspired quite some people about seeing how these robots function. And it was really fun to be there, and I think a lot of people also enjoyed having this cool thing to show. So that was actually already it for the introduction about RoboTeam Twente. And now I would like to give the word to Lotte to go more in detail about the technical plans of this year.
Hello again, and thank you, Alan, for the nice introduction. So we've ended up at the technical part of our presentation. My name is Lotte Steenmeijer, and I'm the technical manager this year. It's my job to oversee all the technical sub-teams and make sure that they stick to the technical planning. Also, that at the end of the year we'll have working robots and hopefully do our best at the RoboCup at Bangkok. So I'll be telling you something about the designs we'll have for this year, which hopefully we'll take with us to Bangkok. So to actually play matches of soccer, we need to have robots, 11 of them to be exact. These 11 robots also need to be able to do a variety of different kinds of functions. These functions are made possible by different parts of our sub-teams, and as Anne already told you about. So we have software, control, electronics and mechanics. The software part is the brain of our robot, and they'll figure out where the robots need to go and send commands to the control part. Control is the code that is run on the actual robot, and it will make sure that if you say go with that speed, that it actually goes with that certain speed. Then we have the electronics part, which will make sure that the mechanical parts do as they're supposed to do and also have the power to work. The mechanical parts are all the motors and the wheels and the physical stuff on the robot. So the first thing that the robot needs to be able to do is drive around. As you can see on the video, our robots can drive around very flexibly to all kinds of different directions. This is made possible by our 4 Omni wheels, which are driven by our Maxon motors. Omni wheels are special kinds of wheels because there are one big wheels with all kinds of tiny wheels on them. These tiny wheels, which are perpendicular to the big wheel, make it possible to move in all different kinds of directions. This is very useful during play because you can quickly move around and switch the direction you're facing in. Another thing a robot needs to be able to do is kick the ball. As you can see on the video, this is a horizontal movement that the ball goes forward, which is used with passing the ball to other teammates, robots, and also shooting the ball in the goal, which is very nice if that happens. The kicker is actuated by a solenoid, but what is a solenoid? Solenoid, you can think about a plunger in a pinball machine where you pull it back and it shoots out and shoots the ball forward. That's also kind of what the solenoid does. It has a sticking out part which shoots the ball. We'll also talk a bit more about solenoids later on in the presentation, as we've done we'll do some improvements of them later this year. So chipping is the second thing that the robot needs to be able to do. As you can see on the video, it's not only a horizontal movement, but also a vertical movement. This is mainly used by our keeper to be able to defend the goal easily. If an attacker robot from the opposing team is coming at you with the ball, and it shoots it at the keeper, and the keeper just shoots it back horizontally, it might be that it bounces off the attacking robot and back into the goal, which you don't want to happen because you want to defend the goal. So by using the chipper, you just chip it over all the other opposing robots and then make sure that the ball is safely removed from the goal. The chipper is also actuated by a solenoid. Another thing that the robot needs to be able to do is to dribble the ball. You can see this on the video. The dribbler is also powered by a motor, and it generates backspin on the ball, which makes the robot able to retain the ball. This makes it's nice to retain the ball because then you can move the ball around on the field, which is nice to do if you want to move the position of the ball or move the robot with the ball to another location on the field. The dribbler is housed in the front assembly, which also houses another important part for a robot, mainly the dampening. If a ball is shot at the robot and it wants to retain that ball, if you don't have dampening, it will just bounce off, which you don't want to happen. So that's why we have the dampening in the front assembly. We'll also discuss this a bit more later on in the video or in the presentation, because we'll be talking about this for the new designs. Lastly, the electronics of the robot. We have 3 main circuit boards, namely the top board, the bottom board, and the back board. The top board is mostly used for controlling the movement of the robot and also the communication with our base station, which is a different circuit board which is used to control all the robots. These electronic parts are used to power and also control the mechanical components of the robot. The second board we have is the bottom board, which you can see on the top right of the slide. The bottom board powers the kicker, the chipper, and also the dribbler, and also does some power regulation. You can see a big red thing on the bottom board. This is their capacitor, which generates high voltages, which are used to power the kicker and the chipper. As you can see on the slide, the top board is actually placed at the top and the bottom board at the bottom of the robot. We're not that creative with names. The backboard is the one which now appeared, and it connects the top and the bottom board to each other, and also has a yellow thing which is used to connect the LiPo, which are our batteries. So that was it for the explanation of the current hardware, but we'll be also looking a bit more into what we improved upon this year. So now we'll go over to our modular design, which was something we improved upon this year. Matches, we only have a limited amount of time to fix our robots, because same as with regular soccer matches, soccer players end up on the ground and they are kind of broken. That can also happen with our robots. So in this limited amount, it should be easy to repair the robot and make sure it works again. The modular design groups the functionalities in different modules, which places the mechanical and electronical parts together. By using these modules, it's also easier to diagnose what's wrong if something of the electronics breaks. This year we'll lay the basis for these modules, and next year and hopefully also the coming years we'll keep on improving those. So now we go over the mechanics a bit more, what we want to improve this year. There are two main things which we'll be improving upon. One of them the front assembly, and the second one the solenoids. So the front assembly is the thing that houses the dribbler and also the dampening behavior of a robot. The solenoids are the one that make sure that we can actually kick and chip the ball. So first, the front assemblies. As you can see on the slides, on the left side there's the old front assembly, on the right side there's the new front assembly. The main problem with the old assembly was that the dampening would break a lot and was very inconsistent in its behavior. With our new dampening, instead of using sponges, which we had in the old ones, we'll be using inerters. Inerters are something which were invented in Formula 1 for a suspension of the cars. And they were working so well that they were banned because they were doing so well. So hopefully with this new inerter dampening, our robots are also doing so well that they will be banned. Inerters will move the horizontal movement of the ball and the vibrations to a rotational movement. If you want to know more about this, at the end of this talk you can discuss this with our mechanics team. You can also see on the right hand side the purple parts, which are the parts which will always remain fixed on the bottom plate of a robot. The purple parts will remain there, but the black parts can be taken out. There are two pins on the side which you can take out, and then you can take the whole front assembly out. This is because of our modular design. So, for the front assembly. The new front assembly will be better for on-the-go repairs, and also will have more reliable ball impact absorption because of our inerter in the design. So now we'll take a bit of a closer look at the solenoids. On the left-hand side you can see the old solenoids, and on the right-hand side you can see the new solenoids. The new ones are way more compact, and because they're grouped together instead of two separate solenoids. This will make better use of the available space, which will give us more room to do other stuff in the robots. Now you can see the solenoids in the robots. On the left-hand side again the old ones, and on the right-hand side the new ones. The old solenoids were placed on the bottom and the middle plate, and the new ones are grouped together both on the bottom plate. So this also saves, here you can really see that it saves up space. So the solenoids. The new ones will be way more compact, and instead of using off-the-shelf solenoids, we'll be using solenoids which are custom made by us, which will give us more space in the future to even improve them further and do everything we want with them. The new ones will also have better weight distribution because they're both placed on the bottom plate, instead of split up in the middle and the bottom plate, this giving us the better weight distribution. If you're one of our partners or you're working at the company and think, oh, I can really help you guys with this, then we would really like to know, because we would like these solenoids to be produced by a company for more consistent and also reliable behavior. So please join us at the end in the discussion if you have some more ideas about this. So now we've gone over the mechanical parts of our design, and we want to take a closer look at the electronical parts of our design. We'll be designing a new back and bottom board this year. The backboard was the thing that connects the bottom and the top board, and also has the connector for the battery in there. The bottom board will be powering and controlling our kicker and chipper, and also the dribbler. So, what was wrong with the old ones? The old bottom board especially would break quite a lot, and was very hard to diagnose where it exactly went wrong, because everything was grouped into one big board instead of having different modules based on functionality. So we'll be making 3 smaller circuit boards instead of one large one. The new design will be more robust and also more reliable, and we'll also add a voltage meter. This is because we use special batteries which you can recharge quite a lot, but if their voltage gets too low, you can't recharge them again. So that's why we added the voltage meter, and hopefully this will save some lipos. Now we'll go to the next slide, which might look a bit daunting, but you don't have to understand everything. It's an overview of the schematics of our new circuit boards. As you can see, the old bottom board would have the functionality of the new power board, kicker chipper board, and the new front assembly board. The power board will have some regulators which will regulate the 24 volts into 3 and 5 volts. And I did this one as the easiest to break, so it's very nice that it's a separate board, so we can easily swap it out. The kicker and the chipper board has some high voltage circuitry on there, so also an isolator, because the highest voltage power can cause other things to break, so that's why it's nice to have an isolator on there. The front assembly board also has a connection for the encoder motor of the dribbler, which will be nice in future for a control code, which I'll explain a bit later on in the talk. So now we go over to software. As we've discussed the mechanical and the electronic parts already, those are powered by the control code, which is mostly run on the robot itself. The control code also has to get some commands, which are followed by our AI, which is run on a computer. The AI calculates what next move our robot should make and send this to the base station, which is connected to the computer, and will send the commands to the robots, which the control code will make sure that the robot, when you say go with this speed to a certain location, it actually does that. So now over to the control improvements. What we did this year, we added a new dribbler controller, and we also redesigned the control code architecture. The dribbler controller. Our old dribbler could only really turn it on and off because we didn't have any connection for the encoder. But with our new connection for the encoder on the new circuitry board, we can also create a dribbler controller, and we can regulate their speed. This regulated speed will improve our ball handling significantly, and that's why we want to make the dribbler controller. We'll also be working on restructuring the hierarchy of the control code. This will make a more robust and easy to maintain control code, which will hopefully help the future generations to work on the code and fix it. So now we'll look a bit more into the software and the artificial intelligence code. As you can see, we have a field with 11 robots, but not only do we have 11 robots, we also have 4 cameras hanging above the field. So we know at each given moment where the robots exactly are on the field. We have one autonomous control, which is run on the computer. This acts as the brain for a robot, and it calculates where the robots need to go on the field. This data is then sent to the base station, and you have the cameras, which are connected to the computer. Computer calculates where the positions of the robots are on the field, which is then sent to the artificial intelligence program, which calculates based on the positions of the robot where the robots needs to go next. This data is then sent to the base station, which sends it to the robot, which will eventually perform these actions. But how exactly is our artificial intelligence program working? It's based on an STP hierarchy structure. STP stands for skill, tactic, play. Skill, the role, as you can see on the slides, there's also a role, but this was later on added, that's why it's not in the acronym. So we'll go over an example to explain this. First, we pick a play, or the AI will pick a play which is best in this situation. For example, this can be an attack play. This will give certain roles to different robots. One of these roles can be, for example, an attacker role. The role exists out of multiple tactics. One of these tactics can be get the ball. So our robot will go to the ball and get the ball with the dribbler and all the other parts we discussed earlier. The tactic then consists out of multiple skills. One of these skills can be go to position. So to get the ball, you first have to go to the position of the ball. When this is finished, it might need to rotate, so that can be a next skill which is need to perform. After this skill is done, the tactic is also done, and it might go on to the next tactic of the role. So that was a small overview of our STP system, but what do we want to improve this year about the artificial intelligence software? We want to stabilize the current skills and plays. We also want to research some new plays and then maybe make some cooperative plays. And we also want to look into the possibilities of machine learning in our AI program. So, to stabilize current skills and plays. Because of Corona, we did less physical testing over the last few years, and thus some of the edge cases are not working properly. To make sure that everything works very well, we want to really test it thoroughly. So we'll also be using the STP system for this, but we'll start at the bottom and slowly make our way to the top. So we'll first fix the skills, make sure that they're really working well, and then go to the tactic, to the roles, and eventually end up with well-working plays. This will hopefully create a good and stable basis for the coming few years and also make it easier to test in the future with test classes and physical tests that are behaving very well. So the next thing we wanted to improve is the new plays. We want to research some other teams and also physical sports for this. You might think because we do soccer with our robots that we would mostly look into soccer. But that's actually not the sport that's most related to how our robots play. Because the ball is moving so fast and the robots are relatively slow relative to the ball, we actually can take a better look at hockey. So we'll be looking at hockey, but also at lots of other sports. Hopefully with these new plays, we'll improve our chances of winning and our game will also improve. So lastly, one of the goals of our team is to innovate and inspire in fields of robotics and AI. Machine learning is one of the subfields of AI, and we have still lots to gain there. So that's why we want to research machine learning in related field and see how we can use this and implement this for our artificial intelligence software. We want to create and test implementations and see how they work with our code and hopefully pick the best implementation for us. That was the end of my part, so I'll give the word back to Anne, which she'll tell you some other things.
Yeah, thank you, Lotte, for all the designs of this year. We have heard the designs for both mechanics, electronics, control, and AI. And with that, we are hoping that we're able to qualify and compete in the World Championships of Robot Soccer next year in Bangkok. But to qualify and win, there's still a lot to do. We have technical challenges that we have to overcome, but also, of course, other challenges. And for that, we could use your support. For this, we have set up a crowdfunding. And any donation, big or small, could really help us get to the next step and be able to be as competitive as we want to be. So we know that there's also a lot of old RoboTeam members out there watching this stream. And because our branding is now purple, you might be excited to get some purple merch in return as well for this crowdfunding. But we do not only need money, but we also really need expertise. We have expertise from our RoboTeam community, but also from the partners that are hopefully watching right now. So for that, we are really hoping you join us in the discussion to think about the designs that we just presented to you and to also give us opinions on what we could do. And for example, even partnerships where we might be able to get your expertise on how to produce things such as the solenoids. For the discussion, we will be using an online platform where you can walk around and go into specific rooms where our sub-teams are. You can also have individual discussions there if that is easier for you. For that, you will have to go to the link that we will be posting in the YouTube chat as well as on our website. You'll have to fill in your name, take a quick picture of your face, and then you can start walking around and you can see us all in there. We'll probably need a few minutes to start up our laptops and join you there as well, but we're hoping to see most, if not all of you there, as long as you have some good questions or you will just want to listen in on the discussions going on there. And without further ado, I want to thank you again for being here today. I want to thank all of you, and especially also the team that is around me here that you cannot see. We've really enjoyed presenting our plans, and we hope to see you in the future in a physical event and right now in the discussion. Thanks again, and we hope to see you soon. Bye-bye.